So we are going to prove that if a function has a two-sided inverse, then it is bijective. Let's first review what a bijection means. Suppose we have a function f that goes from a to b. It's injective if the only way for the outputs of the function to be equal is if the inputs are also equal. So if f of x equals f of y, that must mean x equals y. The function is surjective if for every element in the codomain, there's some element in the domain where f of a equals b. So every output is associated with at least one input. So what is a two-sided inverse? Well, if we have a function f that goes from a to b, then the two-sided inverse, f inverse, is going to go from b to a. And there are two conditions that we want this inverse to satisfy. First of all, if we start with some a in the domain, we take f of a, and then we apply f inverse to that, then we want to get a back. And similarly, if we start with some element in the codomain, and then we apply f inverse to that b, and then apply f, we want to get b back. So let's suppose we have some function f with a two-sided inverse. We want to show that means that f is bijective. So let's start with a condition for being injective. We start with supposing that f of x is equal to f of y. Well, we know that we have this condition for the inverse. So if we have f of x and f of y, we can apply f inverse to both sides of the equation. F inverse of f of x must equal f inverse of f of y. And we know that when we apply f inverse of f, we just get the original input back, x equals y. And therefore, if we start with f of x equals f of y, applying the inverse gets us x equals y, so the function is injective. So now let's look at the condition for being surjective. We start with some b that's in the codomain. We want to show there's some element of a such that f of a equals b. Well, we know that f of f inverse of b equals b. And so if we start with this element b, and we look at f inverse of b, which is an element of a, we know that f of this element of a is going to give us b. And we can do that for every single element in the codomain. Therefore, f is surjective, which means it must be a bijection. Therefore, if a function has a two-sided inverse satisfying these conditions, then that function must be bijective.